I just want to make a quick YouTube video about what it is exactly that I'm working on right now. So this project is actually one of my bigger projects right now, or more important projects rather, because what it's doing is it's loading in all of the data that I've downloaded over the past few months, and it's running it through Handbrake, through a custom preset that's going to make sure that everything is HEVC and AAC audio. So what it does is you set up your Handbrake preset, and this is the Handbrake Pojos, which basically takes in the preset, makes it a Java object so that I can look at what's inside the preset and I can start to understand exactly what it is you're demanding out of the encoder. And then there's the media info section, and basically what it does is it runs media info on a file, determines the video and audio codec, and if those two don't line up with the Handbrake preset, then it's going to run through Handbrake CLI using the preset, and then it's going to output the file back to the server. So right now what it's done is it's downloading. No, actually it's not downloading. It has finished downloading an episode of Aqua Teen Hunger Force. Now it's encoding it, and then eventually it will send it back and delete all the local files. I kind of want to just wait for one of those to finish, so we'll go on to the next one just so I can show you how it all looks here, and one of the major issues that I'm having. Oh, good. Finished enforcing. It's moving it back. Okay, so this is what's happened. It's moved the MP4 to the local directory, it's encoded it, and it's saved negative 28.64 megabytes. And the reasoning for that is, if you look at the Aqua Teen Hunger Force original file, you'll see the first audio stream is 191 kilobits in a really low resolution with a really low audio stream. So if I go over to this is one that I outputted as well. So that's the original, that's the new one. So you can see, let me just have a look at everything that's going on here. It's 48 kilohertz. I want to see actually text. And we'll do the same on this side. So the file size originally was 21.3 megs. The file size afterwards is 35.4. The overall bit rate here is actually increased in size. So has the audio 66.2, and this brings it up to 320, I believe. I don't know why it's not listing that here. But anyways, one of the bigger issues that I'm having is the bitrate seems to go up with H.265, which isn't such a big issue because I really want the quality to remain here, especially since this is such a low file size. The bigger issue is that sometimes when you get low quality, I'll just show you, when you get low quality audio in and you want to run it through Handbrake, so that's my original file, the audio is set to a preset bitrate. And right now, the audio coming in is decent. Some of the other ones were actually like 64 kilobytes, which I can't do, and there is no way for this to be automatically selected. So what I need to do here, in order to prevent things from growing in size, is, inside of the media standardizer, in the media info section, there will be a section that, I'll just bring this back up, we'll view the JSON for it. There's a section that talks about format audio. It's currently in AAC, and the sampling rate is there, so you can select that, but that adjusts automatically. There is a setting to do that. And then, why is there no bit rate? Maybe it's sampling count? Either way, essentially what I need to figure out is how to load in the audio here so that if it's 96, I can adjust the H.265 template on the fly. So if I look at the JSON that's coming in, you can see that it's looking for an audio bitrate of 320. So with my Pojo, I can just set that to something else. So when media encoder or media info loads in the file, it can load in all these variables and determine which ones are right and which ones are wrong. Now for the most part, a lot of these ones will be all just the same, but with the audio and video bit rates and things like that, you can change those in here. So that's kind of what I intend to do. So the idea with this project is that you'll be able to point your program to a specific directory. Now this here is actually a symbolic link to a network server. This doesn't actually exist on the C drive. So it's loading in from network drive, scanning it with media info, and then if the codecs don't line up, it re-encodes it for me. And that's actually, I pulled about 400 gigs out of my ass on the TV side. So if we have a look here, there's about 25 gigs free here, 20 gigs there. Ingest is starting to get backed up because my F drive is full of title downloads. So disk space is becoming very dear. So when I upgrade my drive, this will be upgraded to a 16, that 8 will go here, that 4 will probably go into the desktop to upgrade this one, and then I'll have a 4 and a 2 terabyte in the desktop. So that is the media standardization program. Can I show this? I think I can show this. This is a YouTube Sonar downloader. So I enjoy watching the Hot Ones YouTube show. And so what I've found is inside of... Oh, it's dead. I have to fix that. I'll fix that later. Anyways, inside of Sonar, there's a database entry with TVDB, I think. And somebody's gone along and put the show into the database and then put all the episodes into the database. So I have a nice list of what the shows are, or the episodes are. So what this does is it links into the SQLite database, which is at that directory, and then it's loading in a playlist as JSON using the YouTube DL program, and it basically just returns a JSON of all of the YouTube videos that exist in this, and the parameters that I have set is it's basically just giving me the name and the ID for that video, so that I can go youtube.com/watch ? V equals, and then the ID to play that video file. So it creates the SQL thing, and then it's going to get matches. So get matches is looking at the list of episodes that was retrieved from the database as well as the playlist, and if it finds two titles that look to be the same, then it's going to check whether or not it should download. And the should download basically makes sure that the YouTube video isn't live, because I don't want to stream it and have it caught up. So this get best video format loads the YouTube video JSON data, and then it looks at all of the different formats that are available. So you've got anywhere from 144p to 4K, and those have different bit rates and different file containers and all of that. So this selects the best format that I want, depending on which video size I want. So with the video sizes, where did I put that? Sonar? Video sizes. I've basically taken 144, 240, 360, all the way up to 2160, which is 4K, or an unknown format. So if you equal these dimensions, then you're equal to this size. So I am specifically looking for things in 720, because I don't need crazy quality from people eating chicken wings. And then it downloads the video using the YouTube downloader, and the best selected format. It's going to create a season folder, as well as an episode number, and then the actual name of the episode, just the way that Sonar would. And then it's going to attempt to place those back into the directory where Sonar wishes to have it. And then eventually Sonar will scan that directory and pick up on the files, and then make sure that it's cataloged in the media downloader, but it will show up right into Plex, no problem. So this project's going to be pretty cool. So you should be able to just, like obviously some enhancements need to be made with regards to the playlist and all of that. My current idea was to have somebody specifically say this is where these files exist. So it might be a YouTube channel, it might be a YouTube playlist, it might be anything. In this instance, it's a playlist, so somebody's gone and added in all of the videos for this show into a playlist, and then this thing's going ahead and downloading it. Another approach to that would be to just query the YouTube search engine for the name of the file that you're looking for, but the likelihood that you'll retrieve exactly what you're looking for is fairly high, but not 100%. Whereas with this, you're explicitly saying, please only select things in this area. YouTube DL, if you go to GitHub and you just type in YouTube-DL, just as it appears there, you should see a GitHub repository for somebody that's making it. There's some Python code in there, as well as a Windows executable. It's actually a really nice program. And so that's my YouTube Sonar downloader. That's the media standardizer. That's that. Yeah, we can get into this. So one of my machines is now a VMware ESXi host. And the idea here is I want to create a database of files. So right now what I'm doing is I'm creating a database of files for a very specific set of data. So a lot of it is video, but some of it might be audio, you know, if I want some music, or if there's a good speech or something like that on. But what I want to get more into is just generic files like DLLs or documents or things like that. So this is the heuristics program, or machine. And so when inside most of your virtual machine, most of your virtual machine softwares, there are things called snapshots. And so what a snapshot is if I set up this virtual machine to be just exactly the way it is, and then I move this over here and I reset the snapshot, it will put everything back the way it was. So this operating system, or this VM, is basically going to accept files, it's going to run the files, potentially install the files if it can, keep track of everything that's happened, keep track of all of the metadata about those files as well as the data themselves. So those files will actually exist in a database somewhere, and there will be metadata based on, you know, when did we see it, what's the hash of it, what's some of the deeper dive analytics of it. So if it's DLL, it might tell you who developed it, or the version of it, and so on and so forth. And to that end, I should be able to run queries such as I would like to install Adobe Photoshop. So I'd be able to type in a command, and it will download all of the required files, make all of the required registry edits to the operating system, and then make sure that it all launches in that. And the cool thing about that is for every time that Adobe updates their software, the new file versions will be sent to the database. So if I update and I don't like it, I could basically retrieve the older files from the database and overwrite them over top of the current installation to revert the changes back to a previous version. The other cool thing about this is we'll be able to do deeper dive things like what are the changes between two DLLs. So if there's a DLL version 1 and a DLL version 2, I can use Git to basically look at the file changes and create a change file that will basically take the original file, change it to make it look like the second file, instead of having to retrieve the full second file and overwriting it. And that sort of data will be really important for, you know, keeping track of changes that people make to their programs and so on. So this is one part of this project. The other part is these viruses here, virus 0, 1 through 4. Those are basically virtual machines that are running, that are doing somewhat the same thing. It runs, it accepts a file from API, it puts the file onto the desktop, and then this is where things get a little bit different. For each virtual machine that's here, there will be a different virus scanner running. So that might be Avast, and that might be AVG, and that might be Defender, and we'll obviously have ClamAV in there. And it will all run a virus check against that file, and if it returns positive results, or well, any results in that matter, it will send that back to API, and it will keep track of this. So if there are known viruses inside the database, we can spin up another heuristics VM and run those viruses inside of it to see exactly what happens. I chose ESXi because it's a bare metal virtualizer instead of doing something software like VirtualBox inside of a Linux operating system or something like that. I have access to just about everything, as well as virtual LANs and making sure that there's firewalls and everything like that. So there'll be a pfSense box being put on here to make sure that only traffic that is permitted goes to these VMs. And then there will be a VM network where most of these heuristic VMs will only be able to access the local network that brings you to API, and that's about it. There won't be any internet connection. That's because obviously I don't want to run a virus on here and then have all my other VMs infected and all my bare metal servers infected as well. So this project's kind of young so far. It's coming along. I've been working on this for maybe a year and a half or so, not dedicated to it, but basically just wrapping my mind around exactly what I need from it. What's this? This way. What else do I have on the go here? There's some PyCharm projects. There's a YouTube downloader and a title downloader. So what these projects do is the title downloader, if you look up what's the thing? Maybe I'll put the GitHub project in the description. This project, oh here, just look up this guy. What he's done is he's created a program that decrypts and downloads files from the Tidal streaming service. And so you can download MP3 or FLAC or whatever you really want to do. So what I've done is I have a Tidal downloader and a Tidal scraper. In the Tidal scraper, basically what it does is it fills out this database. So if I go into here, there will be a database full of artist names as well as their ID. So if I wanted music from Billy Joel, I basically just query this ID and it returns a list of tracks and singles and albums and so on and so forth. So there's a pretty good database of metadata on Tidal as to just where to look for what and so on. So that's half of it. The other half downloads those files and places them into my directory here. So it creates a folder directory, and then there's a folder for each band, and then there's album folders inside of it. The particular band that I know is good to go is Alice Cooper. If my fucking computer doesn't freeze. There we go. So it's downloaded a shit ton, and that should be everything that Alice Cooper has posted on Tidal. So if we go into the greatest hits, here's some FLAC files. I don't want that one actually. I quite like. We'll do Is It My Body? And media info. So we've got some pretty good audio coming in. 1600 kilobytes a second, kilobits rather, 48 kilohertz, 24-bit FLAC. It's actually quite nice. Let's just look at the JSON here. There's some other encoding information. There's some copyright information here. There's cover data. So far, the data seems to be pretty fucking awesome. Like, realistically, all I really need to do is take the contents of F, throw it into Z, and then call it a day. All of the additional metadata is loaded in by Plex, which is really nice. What I intend on doing with this is I've kept track of the download locations for each file so that I can separate the LiDAR downloads from the Tidal downloads, because eventually those Tidal downloads will be making their way into packages, and those packages will be, well, you know what happens to packages. Anyways, biggest issue right now is disk space, in case you can't see. So that project's kind of on pause because even the backlog drive is full now. So that's what that does. The YouTube downloader is a little bit broken. This was kind of an old project. So basically what this does is it downloads YouTube videos, it looks up the acoust ID using the FPCalc data. So FPCalc is a program that you run on audio files to generate a unique identifier for that file. That unique identifier is being sent to Acoust ID, the creators of FPCalc. And they have a partnership with MediaBrains, who has all of the metadata for audio files. So for each file, there will be a unique identifier created, but not every unique identifier has metadata available in the database. So this looks it up, and if it finds metadata, then it considers it a song. Then it puts it into the database, and it says, if you want this song, this is where it's at. The idea with this is I want to create a NZB, or not an NZB, it'll be a torrent downloader that will link into LiDAR quite nicely. So Jacket right now, they have, Jacket's an indexer, I don't really know what to call it. Basically, they've got a bunch of indexers in a web UI, and when you query Jacket, it queries all of those indexers for you. So if you're searching for a torrent, you can search it in Jacket, and it will search it on 25 torrenting sites, or however many indexers you have set up. And that's sweet and all, but sometimes there are audio files on YouTube that don't exist in either NZB or in torrent, because they're just not that popular. The cool thing about YouTube is once it's posted forever. So even though it's fucking bullshit audio quality, for particular things like Tiny Tim Little Girl. Type that into YouTube and then find me a download for that song. You can't. So what this will do is it'll allow me to catalog all of those audio files and then serve them up to lidar in order for it to download it. So the sort of the data path of this would be lidar asks the program for an audio file, that program goes out to YouTube, sees if it can find it within a certain amount of time. If it can't, it returns that it can't find it. But if it can, then it will return a torrent file, and that torrent file will be automatically generated and planted into qBittorrent. So I have to learn the qBittorrent API in order to link this so that it will create the file and then send it to qBittorrent so that it can be seeded basically to myself. It's sort of a bullshit workaround for it, but lidar doesn't have a very good import service, so if I were to download all of these and then have it imported and classify it, I just don't know that it would work very well, because it's just not set up to do that. Instead, what it's set up is to go out and fetch new files and then categorize it through that pipeline. So long as I feed it through that pipeline, it should be fine. So it's a little bit of a hacky thing, but eventually those audio files should remain in qBittorrent, but one of my bigger issues right now is, I don't know if I can do this in time, but I'll start it now. The amount of files that I have is ludicrous. This is just the F drive. I still have all of DDC serve, which is my main server, as well as a bunch of other servers and external drives, and I've got USB drives, and I've got shit flying everywhere. My idea is to create a single torrent file for every single file that I have, because for the most part, lidar, sonar, radar, they all work on kind of file names. So if you download an album, that album name would be XYZ, and say there's 16 tracks in XYZ, but only 14 were downloaded. Lidar will look specifically for the 2 tracks that are missing. So when it does its search, it's searching for that file name, not for the album name anymore. And most people upload as albums, not as files. So the problem that I have is I want to upload everything as a file, that way it can just download the whole album by file name, not by album name. But if I were to create a torrent file for every single file that I have here, that's 80,000 torrents that it's got to track at all times and serve to all people always. And that's just going to bog the shit out of any BitTorrenting software. And frankly, I think that my upload is like 30 megabits, so 3 megabytes, which is just not... That's 1.81 terabytes, plus another 2 terabytes just for the music. That's never going to fly. So I have to address that issue. I'm thinking about creating a custom seed box software where it'll probably be in Java, where each one will be a thread, and there'll be some sort of algorithm to decide which ones get priority over which other ones, because obviously there will be some files that are just never downloaded, and obviously there will be other files that are constantly being downloaded. So it would be nice to give a little more precedent to the ones that are actually going to be used. So that's the YouTube downloader. Some other things that I've kind of been working on is there's a program called Fakin' the Funk, and what it does is it loads in audio files and it does spectrogram analysis on it. So if you give me a 320 kilobyte or kilobit per second file, I run it through Mr. Funk, and Mr. Funk will determine whether or not it actually is a 320 file or whether it's lower and been upgraded to a 320. If you're not familiar with audio quality and how encoders fuck it, if you take a 320 or a 96 kilobits per second file and you upgrade it to a 320, you're basically not getting any audio out of that. It's just a bunch of useless replay of the same audio, just to kind of smooth things out a little bit and make the file size and the container settings proper. You're not actually gaining any quality, you're just gaining file size. But when you take that and you shrink it back down, you're fucking the file, because now you've inflated the amount of data, and when it comes around to select the data, it might skip over certain sections and downgrade the quality. So what I do with spectrogram analysis is I look at that and I determine which files are actually fake files, files that claim to be better than they actually are. And I simply just discard those, and I try again. So the cool thing with Mr. Funk is it has that ability, is it has the ability to scan things and then delete it. But it's not addressable by any other program. It's a proprietary software with no API, no command line arguments. It's all UI based, so I would have to manually trigger it, and it takes a couple of hours for it to load in and analyze all of the different files, and then I have to delete it myself. Whereas what I want to do is all programmatic, where you can have this be part of your pipeline, so before it even reaches Plex, it determines whether or not this file is something you even fucking want. So that's something that I'm slowly working on. I have to implement a bunch of audio codec readers in order to load in the different file formats like MP3 and FLAC and OGG and blah blah blah. And then I have to I have to apply my knowledge of how this all works, reading all of the different research papers and that, and actually make a program out of it. That one's going to be a little more difficult, and it's kind of taking a back seat for now, because for the most part, my data is title. Not so much, just random ass files that I found. That will help out a lot with my encoding of movies and TV shows, because I can have a spectrogram analysis on the file before we even determine which audio setting we would like to set it at. So remember before when I was saying that handbrake template can be adjusted using the media info data? You can also run spectrogram analysis to see even if that media info data is correct or not. So you can decide whether or not you want to just go with the media info data, or you can say, no, trust what the spectrogram analysis does, and if it says it's a 96, it's a 320 but it's a 96, then downgrade the quality to 96 to save space. What else do I have on the go? So this is SAB-NZB, or no, not SAB-NZB, it's NZB. NZEDB. And basically what this is, it's a PHP software with web UI, and it allows you to index NZB files. So what I've been doing over the past little bit, since I've gotten my dedicated servers, I've dedicated a specific server to running just this software, and hopefully soon I'll be upgrading it to 4 SSDs in RAID 10. Right now it's just got the 1. And so what this does is it indexes NZBs, and it allows for you to point your LiDAR, sonar, and radar to this site and determine which files you'd like to download through here. The major benefit of this is NZBs are hosted on servers, so when you go to download it, you're not actually relying on a bunch of home internet connections to serve you the file. You're relying on a server connection to send you the file. So long as you have it indexed, you can actually access a lot of data, because some of these Usenet providers, the people that sell you access to the network, they retain data for something like 1,400 days. So anything that's been posted from now till back then is accessible to me. So you just have to parse through the data and see which ones you want, which ones you don't, because just the same as with torrenting, not every file is viable. Some people upload files that are specifically meant for them, it's password protected, or it might be encrypted, or it might be in several different pieces, all of which are unusable. So you might come across things like these, like what that. But anyways, I've got it set up now to the point where it really starts to manipulate the data to make sure that it is exactly what I want. So it doesn't display anything in both the search and the API that is password protected, that is not complete. So you'll see some of these have 100%, and are part repaired, so it'll actually download. That process takes some time. What this is doing right here is it's creating, it fetches these little pieces, and these little pieces get assembled into NZB files, which are similar to torrent files. So that's basically what this is doing right now. And once this is finished, I have to go over and I have to do additional post-processing. So what it does is it makes sure that there's no password, it extracts the RAR archive to see which files are in it, and it does all sorts of things. So these are the groups that it's available on. You know, there's different meta info here, but it'll also tell you, hey, this file contains these other files, and there's some RAR archives in there, and you can search for similar ones if you wish. My favorite ones is if you go over to, well, we'll do movies. I don't know which one would have it, but we'll go this. Huh? No. TV's better for this. Let's try that. Okay, here we go. So if I'm interested in this show particularly, what's neat is the post-processing has gone through and ran media info on it. So I can actually look and see, oh man, this is actually pretty good. It's actually 1080, it's got a consistent constant bit rate, and then it even provides me with a sample so that I can see what exactly it is that I'm going to be downloading. That looks like shite. Oh. But what's cool about this is this metadata is served up through, what do they call it? There's a XML format that they use to send data from here to the different programs, and it includes this as additional properties. So when I do a torrent search, I'm basically downloading blind. When I do an NZB search, I might be flying blind, but at least things are fast. When I do an NZB search against my own and enable the additional flags settings, I'm running as 2020 vision as I can get. So it'll look at the bit rates and everything and make sure that it's downloading the absolute best file. So when I go to search for a file, so say Is It My Body by Alice Cooper, and 6 results get returned, I can look at each individual result without doing any post-processing work and look at it and say, okay, these are, in order, these are the bit rates from highest to lowest, and obviously select the highest one. So that'll help out a boatload. But what's cool about this is you're not limited to just kind of anything. I can also look at what we have in some console section here. So if you want to play Far Cry 4 on an Xbox, and there's something for you. There's an update for a PS4 thing here. So the next logical step is to expand on this. I want to include this section and this section and this section into my media management software, so that I can say, hey, I'd like to download all N64 ROMs, and then I'll have them all, and then I can do version checking and make sure that I have every single version, and then I want to write a web UI to play those games. Or I can run my facial recognition software, which is actually another thing that I'm doing. It's a biometrics database that's going to help me programmatically generate metadata. So I can run my facial recognition software against TV, movies, and porn, just to see who's in those files and, things like that. Then you can do things like, hey, that one person that I really like, I'd like to see more of them. And it'll tell you. As far as that goes, I think this is a fairly long video, so that's basically what I'm working on for now.